Professor Michael Cushing from the University of Toledo. He's a professor of astronomy, director of the Ritter Planetarium on campus at UT, joining me now on the Scott Sand Show. Professor, it's always great to get a few minutes of your time.
It's wonderful to chat with you today.
So beginning last night, I guess, we have a new moon, a mini moon, which is not something out of Austin Powers. We actually have another body orbiting our planet.
That's right. Although its size makes it a perfect Austin Powers reference. So we have a new moon for about 2 months. It's a small asteroid, about 10 meters, or the size of a bus, that generally orbits around the sun, and it got close to the Earth. The Earth's gravity grabbed it, and it'll orbit us for about 2 months, and then it'll go on its way orbiting around the sun again.
This is 2024 PT5. That's the technical name for our new moon.
That's right. That's right. Yeah, it's obscure. It's an obscure astronomer naming convention thing.
Right.
So we like to name things in stupid ways.
Will this affect gravity in any way? I mean, the moon is there in part because of Earth's gravitational pull, but the moon also has an effect on Earth with things like tides and, crazy people on full moons. Will this new mini moon have a similar effect or alter the impact of the moon's effect on Earth in any way?
Absolutely not. So it's only 30 feet in diameter. So when you walk by a bus, if you don't get pulled to the bus, then the bus isn't going to do anything to the moon or the Earth. And so it's just a rock in space that happened to get close to us, and our gravity took over, and it's going to orbit for another couple of months or so.
Does this happen a lot?
It's not infrequent, I guess is what I would say. So in the last, 20 or 30 years, there's maybe a dozen instances of this where every once in a while we'll catch one and it'll come by for a month. Back in 2020, we had one that was orbiting for an entire year, and then it left Earth's orbit and kept orbiting the sun. So it's not infrequent, actually.
Professor Michael Cushing, University of Toledo. So where is this in orbit in relation to the moon?
So the closest it gets is halfway between the Earth and the moon. So it doesn't actually get very close to us. And then for the rest of its orbit, it's farther away. In fact, most of its time is spent outside of the moon's orbit. And so it's pretty far away.
So it seems like if it's coming closer to the Earth than our moon does, that seems potentially dangerous. What could a bus-sized asteroid do if it were to hit the Earth or to hit the moon?
If it were, and there is no way this one is going to, I want to assure everyone, this asteroid has been cleared from the danger list.
Some of us may be hoping for it before November.
I might be on that list too, but unfortunately, I have to believe my colleagues, and so this one is not going to hit us. If it hit us, it wouldn't be the end of human civilization, and it wouldn't be sort of the end of the dinosaurs. But you'd know it. A city would be gone. 30 feet in diameter is a pretty good sized chunk of rock.
But it's not an extinction level event. It's not something.
It is not an extinction level.
How big would that asteroid need to be, and where can we find one?
Oh God! I mean, they're out there. They're out there, and yeah, we'll get through November somehow. We'll all get through.
Professor Michael Cushing here on the Scott Sand Show from the University of Toledo, professor of astronomy, Ritter Planetarium at UT. So here's the other part of the story that I found alarming when I first read about this Friday and reached out to you. We didn't know about this until August 7th. So this asteroid now orbiting the Earth, we've only known existed for 6 weeks. That I find a little alarming because of the potential for a dinosaur-sized asteroid to come sneak up on us someday.
And you should find it disconcerting, absolutely. The good thing is that NASA and astronomers, we think we have all of the civilization-ending asteroids found. Something like 99.99% of the ones that could wipe humanity out. We know where they are, we know their orbits, and we're okay. But there are a lot more smaller ones than bigger ones. And so this particular telescope that is built, it was built specifically to look for these kinds of small rocky bodies that can sneak in without us really knowing. And we find them, sometimes this particular telescope will find one a day before it goes by. And so, yeah, we need to fund this kind of astronomy to make sure we know where all these rocks are.
Do we really though? I mean, if one's going to hit, do we really want to know that it's coming? Do you think they would tell us if there was one that was coming?
That's beyond my pay grade. Let's put it that way. I do know that astronomers are really not good at keeping secrets, and so I can't imagine. That's kind of what makes me think that the government doesn't really hide, aliens, because the possibility of that many people hiding such a big secret to me is not a high probability. So no, I think we would know.
So Professor Mike Cushing here on the Scott Sand Show from UT, NASA, and I forget the name of the organization that tracks the asteroids. You may know it offhand. I think it's part of JPL maybe. But
yeah, there's a couple places, but go ahead.
If we've got 99% of the big ones, the extinction level asteroids calculated, I mean, what goes into that process? What are you doing at if you're an astronomer, what are you doing to calculate these orbits? Are you accurate? How can you know what the orbit of an asteroid that may be outside of our solar system is really going to do?
Yeah, I mean, that's a good question. So, all of the asteroids we're tracking are in the solar system, and the way it works is telescopes look out at the night sky. Stars don't move over time, but asteroids do, and so we can see little streaks of light, and we can identify an asteroid. Once you've found it, you can track it night after night after night, and we can use physics and Newtonian mechanics to actually work out what the orbit is from that. And there's a place in the Cambridge, Massachusetts called the Minor Planet Center that can do this. The one rub is that because the asteroids are small, the gravity of the planets can actually disturb them. And so we can't predict the orbits really, really far into the future, thousands of tens of thousands of years. So we have to keep tracking them. It takes time to keep tracking these things to make sure that they're not going to hit us.
Do we know, using Newtonian physics, when that extinction level asteroid is going to hit the Earth? Because there's one out there. On average, the Earth is hit by one of these like every 50,000 years.
That's right. So we can't go 50,000 years into the future because the orbits are too, what we call chaotic. The gravity from the larger planets perturb the orbits enough that we can't predict it far enough in advance. But there are no large ones, that we know of in the next 100 or 200, I don't know the exact number, years where that's going to happen. And so we just keep tracking them, and we keep updating the orbits, and we keep checking, 200 years in advance to see whether they're going to hit us or not. And we just have to keep doing that.
Fun. Professor Michael Cushing on the Scott Sand Show. What does it take to be considered a mini moon? Are there astronomy requirements for a mini moon?
Yeah, the technical one is that the energy of the orbit has to be negative. So the energy of the orbit with respect to the Earth has to be negative. It turns out that if your energy is negative, then you're bound. You can't get away from something. So the Earth's orbital energy is negative, and that's a good thing because we're bound to the sun. And so it turns out that for these 2 months, the energy of this particular rock's orbit with respect to the Earth is negative, which means it's bound to us. And then on November 25th, it will become positive, it will become unbound to us and keep going around the sun.
So it's actually making an elliptical orbit, but not as fast as the moon currently does, because it's probably, I would assume, a larger orbit in radius.
Yeah, it's not really a sort of a stable, you think of circles or ellipses or that kind of a thing. It's a weird transition orbit right now because it's sort of doing a loop-de-loop around us as it comes in from behind, loops around, goes in front of us, and then keeps going in front of us. So it's a weird sort of, I want to say horseshoe, but sort of horseshoe-like orbit.
Can we see this tonight?
No. So 10 meters or the size of a bus is way too faint to see with your naked eye. It's too faint to see with binoculars, and it's too faint to even see with most small amateur telescopes. You really need a sort of big professional telescope in order to see this thing, and more precisely, a really good clear sight. You got to have a good place to see this stuff. So unfortunately, no, we can't see this thing.
Will we be able to learn anything? What are scientists hoping to gain by being able to study this mini moon for a couple of months?
I suspect, this isn't my area of expertise, but there will be people that will be getting spectroscopy of it, and they'll figure out what it's made out of. There are radar telescopes that will bounce radar off of it most likely to figure out what its shape is, what it looks like. We can actually see if it's, oblong, or is it a sphere, or is it just sort of a rocky pile, that kind of a thing. And it just, it's one more thing that allows us to understand how near-Earth asteroids operate, right? So the more we have of them, the better statistics we have.
If we find out this is made of gold or diamonds, I mean, how close are we to having the technology to send a spaceship up and snag it? I mean, those things are currently in development. They're talking about being able to mine asteroids. Will we see that in our lifetime?
It depends on how your lifetime, my lifetime, my kid's lifetime. I mean, I'm getting up there. So my kid's lifetime, yes, probably. You won't snag it and bring it to Earth. You'll have to do the mining on the asteroid.
I've seen the Bruce Willis movie. That never goes well.
Yeah, no, exactly. But that's the way you're going to have to do it. You can't stop these things. The amount of energy that is in their orbits, they're moving it, tens of kilometers per second. You're not going to stop that thing and drag it to the Earth. So you're going to go up there and you're going to mine it. But yeah, there will be some motivation. It'll be an Elon Musk type person who decides they want to make some real money, and they'll figure out how to get up there and mine these things.
Yeah, these things. This one, I think the mini moon is going at 2,200 miles an hour, or maybe faster than that. 2024 PT5 is its name. I mean, with the laws of I don't know, Newton, Asimov, I don't know, as it Newton's inertia, laws of inertia, right? As it slingshots around the Earth, could the orbit change and might do something that we're not planning for it to do?
Probably not. So it's because it's happening right now, the perturbations due to all the other planets and the sun are not enough to mess up what we predict the orbit's going to do for the next couple of months. Can we predict what its orbit's going to look like in 10,000 years? No, that's not possible. But for the next month or two, we know exactly where it's going to be.
Professor Michael Cushing, UT, what's happening at Ritter Planetarium that you can tell us about?
We've got some great shows. My favorite is on Saturday afternoons. We have Spooky Space. It's a Halloween themed program. And on the last Saturday of October 26th, we want kids to come all dressed up, and we'll hand out candy on that show day.
Love it. Where can we get more information on Ritter?
You can go to Ritter, RITTER.utoledo.edu.
Professor Michael Cushing on the Scott Sand Show. Thanks, Mike. Appreciate you putting up with my dumb questions.
No, these are great. Thank you very much.